Hello and welcome back to compiler programming. Last videos were about some refactoring and improvement in robustness of features we already have. So I thought I would change the pace a bit and introduce some new functionality, but not precisely to the language itself, but rather we need to make some preparations for being able to make a parser for some textual format and then make use of that parser to have a more traditional language where we type some stuff into the text file and then use that to generate the code. However, I want to do something slightly different from how it's regularly done, and I don't want to use existing parser generator, and I don't want to make it by hand either. Instead, since we already have this capability to generate some code at runtime and JIT compile it to functions that we can use, would be quite neat if we created a way to construct tokenizer functions, or at least helper functions for the tokenizer at runtime, and use them for the actual tokenizers that we will use for the language. And we could also change up existing parser for C function declarations that we have to use this stuff as well. Let's start with a test so we can figure out what the API should be and what I want to do at all. It should have a way to create a function that checks if a character belongs, or character is one of this provided set. Now that seems like a mouthful. What does it actually mean? So the idea is, when you write a tokenizer, you go through the input file. So for example, let's just look at what we have here. And you, for each character, you try to figure out how to interpret it. So let's say we start here and we start, okay, we have some new line character. Well, we are not really interested in new lines. At least C is not white space sensitive language. So we just skip it. And then we come to this S, and we say, okay, while we have any alphanumeric characters, and we will just consider all of these an identifier, and then we have a brace, and then we have quotes, and so on and so forth. And for detecting some of them, there are built-in functions in C, but I do not want to use them for educational purposes, and also so we can control more stuff ourselves. But the idea is, would be nice if I could just create these helper functions dynamically by specifying the set of characters that we could use. So let's just say I want to create a function that is gonna check if something is a white space. And we consider white space to be one of these characters. So it's gonna be space itself. It's gonna be the new line. Then we have, sorry about that, we have tab character, and I think that's probably enough for now. We also have carriage return, which causes its own problems because of how Windows and Linux have different convention for what is considered to actually be new line, but we get into that a bit later. So we have a tab, and these would be the characters that we consider to be white space. So what I would like to have is to have a function where I can say create is character in set, and create in character in set checker, function, and I pass this in some form, and I will actually pass this in a form of a string because it will automatically terminate this in null, and we can use this for iterating over this set, right? Oops. So I will do this space /n/r/t. I will then assign it to a function. And let's say that it will be a function type, what it will be. It will be s32 to, it's actually going to be to a boolean, but we're just going to say that it's going to be to s8. And that might also require us to change some things around as to how we handle booleans, but that's okay. Cool. So this will be is white space, right? So we create this function for ourselves that will check for that, and we then need to check if the function that we created actually works. So check is white space of, wow, white space is true. No, we can just not put anything here. And because this already checks for truthiness, let's create a few more. Obviously, we want to say that the other things that we said it should be white space are indeed white space. And then if we say A, it should not be. If we say, I don't know, some letter or number, it shouldn't be. It's a symbol, it shouldn't be. So we should add not into here. And obviously I could very easily write a function like this myself, but the whole idea is that later on we would like to be able to declaratively describe what our grammar looks like and just let this function generation handle the construction of the tokenizer itself. And we will start with something super simple, and if we want to, we can start to employ some optimizations on top of that. For now, I would just create this as if I would be coding it myself, right? Okay, so obviously this fails because, first of all, we don't have this function type. This is something we can very easily fix. We just go into, I guess, this file and add this to the list. Be like so. We get s32 and we get s8 back. And you might be asking, why am I accepting s32 as an input if we are talking about characters? So the thing is, I definitely would not like our parser to be stuck to ASCII, even though it makes things easier. I personally don't think that UTF-8 is that complicated, and I want to support it at least long term. So one Unicode code point is always fits into S32. It actually needs only 21 bits rather than 32, but there is no such thing as 21-bit integer, so we choose the type that is the closest largest type, which is 32-bit integer. And in fact, if you look in Unicode libraries, they almost always type def Unicode code point to being 32-bit integer. Okay, so one of the errors should go away, but still it has no idea what the hell it is create is character in set checker function. So we need to implement that. It will return one of these functions. So this is good. And it accepts const char star characters. Okay, so what that would look like. Essentially, if I was writing this stuff by hand, I would write it something like this. And I will write it so it's easier to translate it to our code as well. We basically say, so imagine I'm writing like not, I have hard-coded characters to be this. So the function would look like if, let me do it here. So we say bool is white space s32 code point. So what if I didn't do dynamic stuff? What if I did it myself? Well, I would do if code point is space, sorry, like this, is space and return true. Okay, then I would have a bunch of these, and then I would say return false. This is what the code looks like. And this is more or less what we can create with our function builders. This is going to be a pretty straightforward translation, but I think it is really neat to be able to construct these kinds of things dynamically. And once we have those, maybe in later videos, we'll start combining them to have bigger things. Anyway, so this is what we want to do. And as I said, this is exactly how we would do it here. We start with function, and the function we call checker. And then we say return value as function. This is a type. And I don't remember if type goes first or the second. Type goes second, so it's going to be checker and then the type. And the function is pretty straightforward. So at the end, we say we actually don't have value from a site, so this is something we will have to add, and it's a good thing because we need to support current cases. I think it's in general a good idea to add features not abstractly, but as you need them. And even though it might seem that what I was doing before it was kind of random, but I was just thinking ahead of what we will need, and now we have even more things that we need to add. Okay, value from S8 0. So this is going to be the false, right? Because in C, false is literally just defined to be 0. In fact, let's go to Compiler Explorer and check what is the size of the Boolean type, because I'm not actually sure what it's defined to be. So let's go here. And the way we will do this is we need to have include std bool.h, and I guess if we enable all the compiler optimizations, oops, ox, then if we say here, actually we can do size of, the type is called underscore bool, which then we don't need even std bool. Okay, apparently we do. So that's interesting, because this is C++. I guess it doesn't know what bool is. But what I want to know, okay, so the size of the bool apparently is indeed S8. So this is what we will need to support. That's good to know. Okay, so this is what happens if we do match the character. I mean, if we don't match, and now we add a bunch of ifs, which are super straightforward. We say if if compare, we need an argument, so we say argument s32 is going to be named character. Okay, take and we say equal character to value from S32, and then here is the loop that we will need to have. So here will go the actual character. Since we get them passed over here, we can just loop over them for, well, first of all, let's assert that we were not passed in an empty a null pointer. Once we know that it's not a null pointer, we say const char star ch is characters star ch and plus plus ch. So if you are not used to pointer iteration, this looks a bit strange. Essentially what I'm saying here is I'm saying, okay, let's get a pointer to the start of the string, which is just an array of bytes. So I'm copying it here, and then I here essentially what I'm doing is saying this. So I'm checking that the current pointer does not point to a null byte, which is what the string termination byte is in C. And then I move pointer by the size of the pointing type. So in this case, it moves it by 1 byte. But if you have something that is not char, for example, it will be int, it will move it by 4 bytes. So this is a bit of a strange thing with C, that you might think that it adds 1, but it doesn't actually add 1. I'm not sure I like it very much as far as language design choice goes, but this is what it is in C, so we are going to it. And generally, I believe this type of iteration might be better. I mean, it's definitely better for strings, and this is why strings are the way they are in C, is because they I believe they wanted to make this type of iteration work, right? You don't want to measure the length of the string and then do this iteration. Also, compilers are not as good at changing stuff, so anyhow. We can just say star ch and then return value from S8 of 1, right? So this is our function, and it's a bit takes a bit of getting used to understand what's going on, because we're kind of writing a macro. This is essentially a macro because it constructs something at runtime. And it's important to understand that this iteration is happening when we run C code, and then C code creates a function that will actually map exactly to what we have over here. If I try to build this, well, it won't know what the hell is a value from S8, is it because we do not have this stuff in our implementation. Let's add it. No, I don't want to open this file like this. I want to open it like this. So let's search for a value from something and continue there. Okay, so value from S32 and value from S8. We have immediate 8, we have descriptor S8, and probably we'll discover a bunch of problems once we start doing this. So, let's see. Okay, it builds, but I doubt it will even run at all or do whatever we want. So I will just right away open dev.env and see where we fail. Cool. Takes a bit for Visual Studio to start up. Okay, let me bring it over here. Did not find an acceptable encoding, which is exactly what I thought would happen. So let's understand where this is going on. And this going on in in this return, so it doesn't understand how to, I guess, move S8 to the result. And here we can also make use of Compiler Explorer and try to understand what is supposed to happen, because well, let's just see what it does, right? So the function would look like what? It would accept so char byte and return byte. This is not a very useful function, but it uses a new instruction which we don't really have, so I'm not sure what it does. Let's try to look up move xx d. Move with sign extension. Okay, that sounds like what we want. And it basically gets the byte and sign extends it to the full value. In our case, it's not really a problem, but it makes sense. So the reason you want to sign extend has to do with how registers work. When you assign a 32-bit value to 64-bit register, the top part is automatically turned to zeros. Or actually, I think it's thematically sign extended to be that. But if you just want to move a byte into the register, then you have a problem. And the problem is that you don't know, you want to override the whole register and just leave that byte with the correct sign in there. And for that, you need either to do this manipulation yourself, or you need to use this special instruction. Okay, well, it's not really a problem for us to use that special instruction, so let's do that. We have instruction.c, we have move over here, so right next to move, let's add our move sx. Say move sx. I will remove all of this stuff because I don't know which encoding we want. So let's add these things, these, and this. Okay. So that's fine. The opcode is 0FBE. And the target is register on the left. And this is an interesting instruction. I'm not even sure what this does. Anyhow, this is the one that we are interested in, actually, this one. But it only works with registers, which is kind of interesting. So we might have to like do a pair of instructions to make this more universal than what we have right now, but it's fine. Let's start with this one. So extension type is register. You can see /r here. The target is register. The source is register memory, but it is specifically register memory 8. And this is something we do not have at the moment. So I guess we'll need to extend the format of operand encoding to match better what instructions have. I will just add this for now here, and I will not go through all of the instructions and change them around. But this is something we need to think about, and maybe this stuff needs to be redone in a different way, such that it closer maps to this. It might also help us eventually to generate this stuff from this HTML or some other source of instructions that is consumable by machines. So let's just say, okay, we specifically want to have register memory 8 encoding. And this is what is going to be used over here. Okay, it builds, but it's fine because we don't actually use this stuff. Now we need to pick up our code and function because here is move value. And this is where, like I mentioned in one of the episodes, that move value will become one of the most complicated functions, and it's exactly because of these kind of reasons, right? So now we need to accommodate the fact that we want to allow to make this move, right? Because the assumptions that the source and the destination of the operands should be exactly the same doesn't match. We could make it in a different way. I believe there is just a way to sign extend a byte to the full register. So x86 extend byte to sign extend byte to word something. No, it looks like I know there is this separate set of instructions, I guess. CBV, CBD, and CDQ. We even already have, I believe we even have this encoded. So what does, no, I don't want to search for. Yeah, so we have CVD, but it sign extends it to different register. Yeah, this is not what we want. So I guess we have to use moves. Okay, that's fine. We can do that. Okay, but what is our logic then? Our logic is it might be easier to here just let anything to be moved and not do size check here, and instead move that size check to be on the encoding part. But for now, I will not do that because that might break other things, and I don't want to. I don't want to do that. So, how will we deal with it? This is not very extendable way to support this kind of stuff, but let's do this. So the logic is if A size is not B size, if B operand type is this stuff, so it's going to be operand type register, actually register or memory indirect or the more I'm thinking about it, the more I'm considering that it might be better to just let the other stuff handle it. Although if we will do it here, we'll need an F. Okay, let's try to do it like so. So we comment this out, but we now say if a parent type is if B size is 1 byte And then we can do things. And a size is less than 4 or less than 8 actually. So if on the right side we have a byte and on the left side we have something that is either 16 or 32 or 64, right? Then we can use this instruction. And we can also say and a size more than or equals 2. Maybe it would be better to change things around so it's easier to read, right? So even though these braces are not required, I think they show better what we are trying to achieve. So if you have byte on the right side and 16, 32, or 64 on the left side, then also we could say, I guess we want to generalize this stuff at some point, but for now I will ignore it. I will say assert that a operand type is operand type register. And we can just use our function to encode this, right? So it will be move as x, a operand, b operand. And then I also need to assert that b operand type is register or essentially that the type is not immediate, which we again also need probably a helper function to do. But for now, let's just try to make the test work. Operand type register or be operand type memory indirect or be operand type rip relative. Yeah, this also kind of shows that maybe our operand types are not the best setup as well. Assert, yeah. Okay, that builds. And let's see what happens when we try to run this stuff. Did not find an acceptable encoding. Okay. Yeah. So here we need to return. And still that's fine, because if we look at what we were trying to do, yeah, it's still here, but I bet it was over here because we don't, inside of encoding C, we need to support this type of memory. And in particular, we will need to add the sizing of the operands, and the size should be correct, otherwise all of this will not work. So here we have, wait a second. Okay. Yeah, this is a problem. So our first issue will be that we check that we don't want immediate to be on the right side, but our function does exactly that, right? It creates an immediate here. So I guess we will need to change that first. Can a regular move move just 1 byte? I wonder. So yes, there is a move that does 1 byte, but we probably do not have it yet here. 88, yes. So this is another thing that we need to take care of. So it is indeed register memory on the left, but I want to have try and specify a simple offset relative to segment. This one is what I want. Move immediate 8 to RM8. So where is this? Okay. So C6 will move immediate 8 to register memory. And actually so for true and false, we don't actually need sign extension. So we could just continue using this stuff and deal with sign extension in a different way. So to clarify what I'm saying, here we return 0 or we return 1. And both of them are positive values. They are less than 128, so they will not wrap. That means that if we just make this stuff work, and if we clear the register beforehand, then we don't have any issue with the size. So maybe that's what we do for now, to not go into the whole thing with different sizes. But I definitely will consider how we want to deal with it long term. Okay, so if we want to do that, that means in here we no longer need to check for the source because the other stuff will handle it, and instead I will recursively call myself. So I will call move value and say A, and instead of B I will need to manually construct a 0 of correct size. And maybe that's something as well that we need to turn into a function where we say, or I guess here's what I could do. I could say value from S64 value star 0 is value from S64 of 0, and then I override the descriptor of this 0 with a descriptor that is for the type that we actually have, which is gonna be A. So 0 descriptor is A descriptor, and this just would make sure that their sizes match. Now we pass in this called function here. What should this called function here? We say A and 0. So we are clearing out the target register, and then we just will write the byte into that. I will add a fix me, say use move sx, and not use it for now. And instead, I will do it like so. Yep, that sounds good to me. So we first move 0 into target location, again to clear everything out, and then we move in the byte that we actually want to move in. Okay, let's see if that actually works. Start again. Okay, this is, I think, just okay. So it looks like it did. Let's try this out. And we have all the tests passing. I would still like to see the assembly before we wrap up, but that will be that. Okay, we don't need this stuff anymore. So actually, let's keep it while we look at the assembly, so it's easier to understand what's going on. Start. We go to disassembly, then we look into this. So space is hex code 20. We go in here, we go into call, and this is our function. Now, this is really inefficient version of what I wrote over here, but I wanted to show how we can generate like very high level code to do what we want. We could also change this around to directly push in the x86 instructions, and maybe that's something we will do eventually, so that it runs fast, because there is a bunch of interesting things you can do if you go directly to instructions, but it's also nice that we can do it without that. And there's also a bunch of optimizations we could do though, so that resulting code is nicer. Okay, so the sub 38 is just for the stack, that's perfectly fine. We move the space into a stack location so we can use it for comparison. We get the value out of the first argument and put it in EX. We compare EX with 20, so like with space. Okay, then we also change array X to 0, so we clear it out. Then we set the byte from the flags that were set in comparison, and then we save array X. We do the comparison again with 0, which is our if. And if it's equal, we go to the end, and instead we continue. So it's basically if the condition is not false, then we like this is the new instruction that we added, this C6 stuff. Let me show you. So this is the instruction that we just added that deals with the byte on the right side and anything else on the left. And then we jump to the end, which will be the return, right? So we restore the stack and we return, and everything works exactly as it should. And this is the branch that happens when all the conditions fail. Good, everything works fine. I will think over how you want to deal with sign extension and how you want to deal with this register memory 8 stuff. So maybe we should change the format. But for now, that's it. Thank you very much for watching, and see you next time.